We are Sunrise Group, a company specializing in new and renewable energy. Let's begin introduction to aqua fuel power generation, which is energy made from water, and the power plant hosting business. Energy is the source of life. It is the lifeline of civilization, the driving force of industry, and the pillar of security. Energy is the most basic element that enriches and makes our lives comfortable. Energy determines our lives and future. However, we have been using fossil fuels to live a prosperous and comfortable life. After the Industrial Revolution, the use of fossil fuels rapidly increased, causing the Earth to become increasingly hotter, causing the climate to reach catastrophic levels. Farmlands are gradually turning into deserts or being submerged by water, and the ocean is losing its vitality. Before we know it, we may be standing on the brink of famine, war, and destruction. Many countries, which have become aware of the absolutely critical climate crisis facing humanity, have quickly started a global campaign to curb fossil fuel use and greenhouse gas emissions, and for the survival of the Earth and humanity. This is the RE100 campaign. Global companies and governments in Europe and the United States participated in this campaign, which started in the UK, but Korea has been indifferent so far. This campaign became a trade barrier and tariff, putting Korean companies that had been indifferent so far into a major crisis. With predictions that Korean exports could decline by as much as 45% and serious warnings continuing, overseas supply contracts have been terminated, putting companies on the crossroads of business failure as well as a decline in their international competitiveness. Now, let's take a moment to look at hydrogen, a key energy transition keyword for RE100 implementation. Hydrogen is broadly classified into 4 categories: gray, blue, green, and white hydrogen. Gray hydrogen, which emits carbon dioxide but produces hydrogen most easily and cheaply using natural gas, and blue hydrogen, which captures some of the carbon dioxide generated during the gray hydrogen production process and buries it underground or in the seabed. Green hydrogen produced by electrolysis of water using renewable energy such as solar or wind power without carbon dioxide emissions. Lastly, it can be classified as white hydrogen, which produces a new type of new energy or self-sustaining power without using renewable energy, electrolyzes water, or captures hydrogen naturally existing underground. Among these, green hydrogen and white hydrogen are internationally recognized as eco-friendly hydrogen. The A-fuel produced by our company is this white hydrogen. These 2 types of hydrogen have something in common. They produce hydrogen by electrolyzing water, without emitting carbon dioxide. Changing fuel is the key to energy transition. Until now, mankind has used hydrocarbons, called fossil fuels. When burning hydrocarbons, that is, fossil fuels containing carbon, carbon dioxide is inevitably emitted. We need to change from hydrocarbons that emit carbon dioxide, a greenhouse gas, to carbon-free fuels. One of the most carbon-free fuels is water. Water is hydrogen oxide with oxygen instead of carbon. Water becomes fuel when decomposed, and is the most ideal energy source as it is reduced back to water after use. Water is not only the most abundant resource on Earth, but is also an infinite and clean natural energy source with no fear of resource depletion due to its property of being converted back to water after being used as fuel. However, because the cost of electricity to electrolyze water was high, people were reluctant to do so for economic reasons. Our company helps you make a quick and economical energy transition by providing solutions that minimize the electricity cost of electrolyzing water and the fuel conversion cost. Let's take a look at the A-fuel we produce. A-fuel is a simple and safe fuel that can produce approximately 1,860 liters of fuel from 1 liter of water and does not require a separate storage tank, as it can be used immediately after production. Additionally, A-fuel is a pollution-free fuel. It is a fuel that burns completely without emitting carbon dioxide or any other pollutants, and can produce more calories than gasoline or LNG. A-fuel is a gas fuel made by electrolyzing water without electricity costs using our proprietary water treatment technology, self-generation technology, loopback technology that feeds back a portion of the produced power, and a new electrochemical reaction method. A-fuel solution is a software and hardware integration technology that produces heat and electricity by directly using A-fuel in existing engines and boilers. A-fuel's electrolysis method, unlike the existing AEM, PEM, and alkaline methods, does not use a separation membrane, and is a differentiated electrolysis technology in terms of water pretreatment technology, reaction promotion technology, catalyst used, and electrochemical reaction formula. This is the most economical and efficient method. A-fuel's electrolysis system can be applied to both seawater and freshwater, producing hydrogen in seawater and fuel in freshwater. Fuel produced from fresh water can be used directly in existing engines, boilers, or incinerators. In seawater, hydrogen is produced without oxygen generation. At this time, sodium hypochlorite, a powerful natural disinfectant that is harmless to animals, plants, and people, can be obtained as a byproduct. Hydrogen produced from seawater can be supplied by compressing, storing, or liquefying. A-fuel can be used for three main purposes. First, it can be used as an auxiliary fuel and alternative fuel to existing fossil fuels. Mixed combustion with existing fuel improves combustion efficiency, induces complete combustion, reduces fuel costs for internal combustion engines, boilers, and furnaces, and suppresses the generation of exhaust gases and pollutants. Second, it can be used as fuel for engine power generation. A-fuel, which has the advantage of large explosive power, is directly exploded within the engine to increase the rotational power of the engine. This rotational power is used to generate electricity with a generator, and a part of the produced power can be returned and used as fuel production power. In this way, the cost of electricity consumed for fuel production can be reduced to zero, and most of the electricity produced can be supplied. Third, it can be used as fuel for existing thermal power generation, that is, turbine power generation. More steam can be produced by combining existing fossil fuels, A-fuel, and steam. The steam produced in this way can be used to generate electricity using a turbine, and the used steam can be used again as mixed combustion fuel. It can be applied by co-firing A-fuel and steam little by little at first, then gradually increasing the amount. This method allows replacing fuel with A-fuel while still using the turbine of an existing thermal power plant. The biggest feature of the A-fuel solution is hydrogen engine power generation. Hydrogen engine power generation using A-fuel is the most economical of the current renewable energy power generation systems, and is the optimal solution to achieve zero carbon because it uses water, an unlimited non-polluting raw material, and produces power in a non-polluting, eco-friendly manner. A fuel power plant has an installation cost and construction period of about half that of existing hydrogen fuel cells, can supply power at all times without interruption, and can be installed anywhere indoors or outdoors, including islands, mountainous areas, underground facilities, and even mobile devices. It can also be installed on trains and ships. A fuel power plant occupies an incomparably small area compared to other systems, can be stacked like a building, and above all, it is the most economical solution with fuel costs and environmental treatment costs close to zero after construction. A fuel power plant can build a smaller or larger power generation system based on 2 megawatts, and can build a power generation system as large as possible with the grid system. By building a grid system, we can supply flexible and stable power according to power demand. A fuel solution has achieved the lowest fuel production cost. The production cost of 1 kilogram of hydrogen is approximately $2. This is because we have established a zero power cost production system by independently producing and procuring the power required for fuel production, which accounts for most of the fuel production cost. If a large-scale plant is built for mass production, hydrogen will be able to be produced at a production cost of less than $1. A fuel power plant is a distributed self-generation system that can dramatically reduce social indirect costs and opportunity costs by eliminating the infrastructure construction period and additional costs required to build a power system. In addition, damage from power supply network problems such as power outages, power cuts, and power outages is greatly reduced, and the system can be operated autonomously according to the plans of consumers and solution operators. A fuel engine power plant has superior economic advantages, as shown in this comparison table, including installation space, construction period, annual power generation time, annual power generation, fuel cost and environmental cost, power generation cost per kilowatt, and investment cost. With a fuel solution, we supply land-based fuels and power generation systems using fresh water such as rivers, lakes, tap water, and groundwater. We supply hydrogen production systems to hydrogen charging stations and embedded fuel production systems to transportation vehicles using A-fuel-compatible engines. The world's leading major global companies such as Toyota, Mazda, Porsche, Yamaha, Benz, and BMW are competing to produce or prepare vehicles equipped with hydrogen engines. The demand for hydrogen charging station infrastructure and embedded fuel production systems required by them and consumers will increase over time. Due to global water shortages, including in the Middle East and island countries where fresh water for drinking and living purposes is lacking, seawater desalination projects have become more necessary. We supply a fuel solution that supplies the energy needed for seawater desalination projects and produces electricity and heat. We build seawater fuel conversion systems on existing abandoned drill ships, abandoned merchant ships, and barges on coasts and islands around the world to desalinate or turn seawater into fuel, and produce and supply fuel and hydrogen. We build embedded fuel production systems on ships, allowing ships to produce and use the fuel they need using seawater. The supply of embedded fuel production systems for ships will be a groundbreaking turning point in enabling ships to achieve zero carbon and fuel costs. We supply a fuel solution to help build new cities and infrastructure, including empty coastal landfills around the world, offshore fuel bases and desalination plants on the coasts, food production bases, industrial complexes, and logistics complexes in the coastal inland. A fuel solution can be applied to various fields. In summary, it can be used in the same way as natural gas in all fields, including boilers, thermal power generation, and transportation that previously used natural gas. Our company develops and services new business models using a fuel solution. It is a power plant rental and power plant hosting business. Now, let's take a look at power plant rental and hosting services. Power plant rental and hosting service is called PPH service, and is a service that can dramatically reduce power system construction costs, fuel costs, operating costs, management costs, labor costs, and installation space based on our proprietary fuel production and power generation technology. This service is a total service for leasing, operating, and managing power generation systems that can solve environmental problems and respond to RE100. PPH service is a new business model in the energy transition period and is provided mainly through centers in each region and base. PPH service rents plants at the village and city level, manufacturing and high-tech industrial complexes, logistics complexes including refrigeration and drying, and IT industrial complexes, including IDC and cloud centers, and provides operation and management services. Companies will be able to conveniently and quickly obtain zero carbon and RE100 certification by simply using the PPH service without having to go through separate procedures and costs to obtain RE100 certification. PPH centers first provide services in industrial complexes and cities in each region. In data centers and cloud centers, PPH centers are established at each base to provide services. Data centers and cloud centers that use PPH services will be able to operate zero-carbon centers while reducing enormous power costs. As you can see in the picture, there are a lot of data centers and cloud centers around the world, and the number is expected to increase further. In particular, major groups such as Amazon, Microsoft, and Google have already declared RE100 and are leading the market, converting the rapidly increasing demand for data storage such as artificial intelligence, virtual reality, and video data into profits. The reality is that existing renewable energy systems and other basic power systems cannot increase the supply of new and renewable energy to match the rapidly increasing data and power demand. In the future, the demand for PPH services for data centers and cloud centers to achieve zero carbon emissions and reduce power costs is expected to increase significantly. As the distance between cities and rural areas, and between production and consumption areas increases, and consumer demand and market structure change, the demand and need for drying and freezing food is gradually increasing. In response to these market demands, the demand for PPH centers in each storage market will increase. In particular, in places where intermediate storage is needed for inland food delivery, such as the United States, China, India, and Russia, intermediate storage that could not be built until now due to power supply issues will be able to be built. Companies that choose this PPH business model will be the winners in the distribution industry. The business we particularly want to do is railway PPH service. As long as we have tracks and trains, we can have clean, safe, energy-independent electric railways and railway infrastructure that can be used anywhere in the world. without needing power plants or electric lines. The Railway PPH service is a project that enables trains without electric lines and supplies power and heat to cities and infrastructure around railway stations. This is the fastest and most economical way to industrialize a large area and achieve balanced regional development. Now let's look at the technology. It might be a little difficult. I will explain it as easily as possible. First, I will explain the fuel production system. HHO water electrolysis technology is a technology that produces fuel through water pretreatment and a new water electrolysis system. The two biggest features of the fuel production system are water pretreatment technology and self-power supply technology. Water consists of many water molecules coming together, like snowflakes, to form a cluster. The larger the cluster, the stronger the internal attraction, so a lot of energy is required to decompose. MCR is a technology that divides these clusters into very small sizes and changes them into a structure that is easy to electrolyze. Small clusters of water allow more fuel to be produced with less electricity. We do not disclose or provide any information about this technology. Self-power supply technology consists of self-generation and loopback technology, and we will provide further explanation through additional materials. The video you are watching now shows the fuel production system and how it produces fuel. With a power of approximately 2.46 kilowatts, 960 liters of fuel are produced per hour. When this is calculated as the power required to produce 1 kilogram of hydrogen and the production efficiency, it represents 42.28 kilowatt hours and an efficiency of 94.69%. This efficiency is thermodynamically calculated production efficiency. If a self-power supply system is applied here, economic production efficiency is calculated to be infinite. We are constantly researching and developing new systems. This video shows the process of our continuous research and development. The video you see in the small window here shows a demonstration of producing fuel using self-generated electricity without an external power supply.
배터리에 충전을 계속하면서 뭘 써갖고 지금 가스 발생기는 718W를 쓰고 있고 아까 뭐 계속 비슷하게 0.1 또 왔다 갔다 하는 거죠. 지금 가스는 정상적으로 계속 생산이 되고 있고요. 720W 이제는 원래대로 먹고 있습니다. 안정화돼서 배터리 변화 없습니다. 지금 이 변화 컨버터가 먹는 전기, PCS가 먹는 전기, 또 인버터가 먹는 전기, 가스 발생기가 먹는 전기까지 다 해서 1kg 이상 지금 생산하고 있는 겁니다. 그런데 지금 모터가 쓰는 전기는 168W. 24V, 예, 배터리는 24V에 60A. 이렇게 지금 이상 없이 돌아가고 있습니다. 여전히 변화가 없죠. 이상입니다.
These are the specifications of the A-Fuel standard electrolyzer. It uses a voltage of 36 volts, a current of 100 amps, and a power of 3.6 kilowatts. It is a fusion of dry and wet electrolyzers with 4 cathode and 4 anode electrode cells each, and a total of 64 electrode cells. This is a standard electrolyzer that produces 32 liters of fuel per minute, or 1,920 liters of fuel per hour. The electrolytic efficiency target for this electrolyzer is approximately 95%. By organizing this electrolyzer into one system, we create a fuel production plant that produces fuel equivalent to 1 kilogram of hydrogen per hour, that is, 9 kilograms of A-fuel per hour. As we know, water does not exist in only 3 forms: solid, liquid, and gas, ice, water, and water vapor. It has been discovered that surface water, a different form of water, is instantaneously created at the interface between water and other substances. The fourth type of water, surface water, is cathodic and has been found to be a semi-liquid state with properties of both ice and water. We demonstrated through the polarity arrangement process that such surface water and general water participate in electrolysis in the anode and cathode electrode cells, respectively, and developed our own electrolysis technology using that principle. Reorganizing water into very small clusters with MCR increases the amount of surface water at the interface between water and electrodes, increasing the amount of charge and energy, thereby improving electrolysis efficiency.
You've all learned in school, in middle school, that water has 3 phases: solid, ice, liquid, and vapor. Well, we uncovered a 4th phase of water. It turns out that there are unexpected applications to this. The first one is getting energy from water. The way this water forms is very simple. Whenever water meets hydrophilic material, by hydrophilic I mean water-loving, it undergoes a radical transformation. That we were astonished to see this, that the water molecules are actually lining up with one another in some ordered fashion. Like a liquid crystal, if you will, it's H3O2. Particles, and later we found molecules, are progressively excluded from this zone that was sitting right next to the surface. We also call it the exclusion zone, or EZ for short. This 4th phase of water is not neutral. Typically it's negatively charged, and the water just beyond it is positively charged. And as you might guess, if you stick 2 electrodes, one in the negative, one in the positive, you have a battery, and that battery can light a light bulb, for example, and we've demonstrated that. And we found, to our great surprise, we really didn't expect it, that the input energy comes from light.
A fuel system can also electrolyze seawater. Only hydrogen without oxygen can be produced from seawater. The reason we are focusing on seawater electrolysis is because mass production of hydrogen will be necessary in the future, and it is difficult to supply the large amount of water needed to produce large quantities of hydrogen using only fresh water from land. Climate change will gradually lead to water shortages on land. This problem can be solved by using seawater. Now, let's take a look at the pollution-free, high-efficiency power generation system that uses the explosive power of a fuel and the rotational power of the engine. This video is a concept video showing a model of the engine power generation system using a fuel, using a small engine and generator. At first, power is supplied from the battery and water electrolysis begins. Next, electricity supplied from the battery is used to electrolyze water, and fuel is produced from water. Next, the produced fuel is supplied to the engine. Then, the engine explodes the supplied fuel within the cylinder and rotates the central axis of the engine. By connecting the central axis of the engine and generator, when the engine rotates, the generator also rotates. The generator produces electricity, and the generated power is charged to the battery. While charging the battery, the remaining electricity turns on the light bulb. In order to produce fuel and supply it to the engine, the water electrolysis tank receives the electricity charged in the battery and produces fuel with water. By continuing to repeat the process so far, the circular process of supplying power from the battery, producing fuel, supplying fuel, operating the engine, rotating the generator, producing power, recharging the battery, and supplying excess power to the outside continues to be repeated. This circulation process is the basic concept of the A-fuel engine power generation system. This video is a video of a large engine and a large generator operating on the same concept as the concept video we saw just before. This video shows how A-fuel is produced with a power of approximately 4.2 kilowatts and 6 horsepower, rotating a 61 horsepower, 45 kilowatt engine at 3000 RPM, and connecting a 24 kilowatt output generator to this engine. What is important here is that the A-fuel was produced by supplying 4.2 kilowatts of power, rotating the 61 horsepower, or 45 kilowatts, engine at 3000 RPM. More details will be explained in the next slide.
RPM이 4,000? 3,100 RPM까지 돌렸어요. 오케이, 이상 마치겠습니다. 선생님 수고하셨습니다. 수고하셨습니다.
Previously, we saw a video of A-fuel producing a power of approximately 4.2 kilowatts and 6 horsepower, rotating a 61 horsepower, 45 kilowatt engine at 3000 RPM, and connecting a 24 kilowatt output generator to this engine. Here, the 24 kilowatt output generator can be replaced with the up to 210 kilowatt output generator shown in the picture. You can even replace the alternator with a smaller, more efficient engine. We are showing the configuration of the A-fuel engine power generation system. It has the same structure as the system in the video you saw earlier. This configuration shows the configuration of one module. The power plant is equipped with 3 to 6 engine generator sets. A-fuel power plant has an engine power generation system as standard. A-fuel power plant can be used not only as an installed type, but also as a mobile and vehicle-mounted container generator. A-fuel power plant has a built-in fuel production and supply system. The fuel production and supply system includes an electrolyzer system that electrolyzes water, MCR, a water pretreatment device, and MRD, an electrolysis accelerator. It also has a built-in loopback system and power supply system to produce fuel using its own power. A-fuel power plant is a container-type plant and has 1 megawatt, 2 megawatt, and 4 megawatt systems. The standard model has a 2 megawatt power generation system built into a 20 feet container. The 4 megawatt plant is a 4 megawatt power generation system built inside a 40 feet container. The basic structure of the 4 megawatt plant is an A-fuel production plant and 10 sets of engine generator modules. The basic structure of the 2 megawatt plant is an A-fuel production plant and 6 sets of engine generator modules. Systems below 1 megawatt are based on an A-fuel production plant and 3 sets of engine generator modules. A-fuel production plant is a gas production and supply module using a water electrolysis system. The 4 megawatt power plant consists of 10 sets of standard model A-fuel generators. There are 6 sets for systems under 2 megawatts, and 4 sets for systems under 1 megawatt. In large plants of 10 megawatts or more, the A-fuel production plant and engine power generation system are separated and each plant is constructed to build the site. Let's take a brief look at the configuration of the 2 megawatt A-fuel engine power generation system. The 2 megawatt plant, supplied in a 20-foot container system, has a maximum output of 4,800 kilowatts, a rated output of 2,100 kilowatts, and an output voltage of 380 volts 3-phase. The output voltage can be adjusted to 440 volts, 680 volts, etc. upon request. Inside the 2 megawatt standard power plant, 1 A-fuel plant and 6 engine power generation system modules are built in. Of the 6 engine power generation system modules, 5 are operating and 1 unit is on standby for rotational operation. Modules that fail during operation are immediately replaced by modules waiting for rotation, and modules that fail are repaired or replaced. Of the rated output of 2,100 kilowatts, 100 kilowatts are loopbacked for fuel production and internal system operation, and 2,000 kilowatts are output. When temporary peak power is needed, peak power can be output by either operating additional modules on standby or increasing the generator output by increasing the engine rotation speed. A 2,000 kilowatt power plant can output peak power of up to 4,000 kilowatts. The A-fuel engine power generation system supplies fuel produced by electrolyzing water in an A-fuel generator, that is, an electrolyzer, to the engine, and the engine combusts and explodes the supplied A-fuel within the engine cylinder to rotate the engine's rotation shaft. When the engine rotates, the generator connected to the engine's rotation shaft rotates with the engine to produce and output power. In an engine power generation system, the engine plays the role of a motor or turbine rotating a generator in a typical power generation system. The embedded generator built into the engine produces less than about 5 kilowatts of electricity needed for fuel production and supplies it to the electrolyzer through a loop back, allowing the electrolyzer to continuously produce fuel and supply it to the engine. By continuously repeating this process, power is continuously produced and supplied without electricity or fuel costs. A-fuel increases the torque and RPM of the engine and amplifies the rotational power of the engine with a faster combustion speed and greater explosive power than existing fossil fuels. The A-fuel engine power generation system is constructed using these A-fuel characteristics and A-fuel compatible engines.
Let's take a look at the mixed combustion system of A-fuel and existing fossil fuels to save fuel and reduce pollutant emissions. A-fuel can be used by mixing with existing fossil fuels in almost all internal combustion engines, boilers, heating furnaces, and incinerators that use existing fossil fuels. The easiest way to mix with existing fossil fuels is to mix A-fuel with air when supplying the air needed for combustion. In systems of a certain scale or large plants, an additional mixing and dispersion pump is installed to mix A-fuel and existing fuel, and the existing fuel and A-fuel are mixed in advance and supplied directly to the combustor or internal combustion engine. When mixing A-fuel and existing fuel can be saved, and since A-fuel acts as a high-temperature kindling, it prevents delayed combustion of fuel, increases combustion efficiency, and pollutes. The generation of substances can be suppressed. This video is a demonstration video of mixed combustion of 80% LPG and 20% A-fuel. As a result of mixed combustion, LPG was saved as much as A-fuel was used, and engine torque increased. At the time of the demonstration, in May 2023, 20% of A-fuel was produced and supplied to the engine with 4.2 kilowatts of power. In January 2024, the system was upgraded to produce the same amount of A-fuel at 2.46 kilowatts of power. In small boilers, industrial boilers, incinerators, power generation boilers, etc., a fuel mixing pump can be used to burn a mixture of A-fuel and existing fossil fuels, a mixture of A-fuel and steam, or a mixture of A-fuel and steam and fossil fuels. This system configuration is when a separate steam generator is used to produce steam to be mixed. By configuring such a system, existing fuel can be saved while simultaneously improving combustion efficiency and reducing pollutant emissions. This configuration consists of a system that produces mixed fuel from existing fuel, A-fuel, and steam using a fuel mixing pump and supplies it to the boiler. The steam generated from the steam generator, which is a boiler for power generation, is sent to the turbine, and some of the steam discharged before or after the turbine uses the steam is looped back to the fuel mixing pump and used to produce mixed fuel.
So far, we have briefly looked at Sunrise Group's A-fuel production and power generation, PPH business, and related technologies. Thank you for your attention.